everyone. Today's topic is going to be solving absolute value equations with the variable on both sides of the equal sign. So we're going to continue our topic on solving absolute value equations. So a few things you need to know when you have a variable on both sides of the equal sign. If there's a variable on both sides, then the solutions must be checked. That means you have to plug in your solutions to the original equation and verify if you have a true statement. So there's two possibilities here. You could either get a false statement or you could get a true statement after you simplify. If you get a false statement, then that solution is said to be extraneous and it is not a possible solution. Now, if you get a true statement, then that solution is okay. That is a solution to your problem and you're good to box it or write it down as your proper solution. As you're doing these, you'll notice that it's possible to have two solutions, or maybe you have one solution because the other solution is extraneous, or maybe both of your solutions are extraneous and therefore you have no solutions. Okay, so go ahead and take a moment to pause the video and copy this down, and then we'll get started on our examples. Okay, so here we have our first example. We have the absolute value of x minus 4 equals x plus 10. So our absolute value is isolated, so we can go ahead and make two equations. My first equation is going to be x minus 4 equals x plus 10, just the same thing. My second equation is going to be x minus 4 equals, and I'm going to put a negative and open a parentheses and then put x plus 10 in there. So now we're going to solve for our first equation. We're going to add 4 to both sides here, eliminating the 4. So we get x equals x plus 14. So now we're going to subtract x from both sides, eliminating both of the x's. So I end up with 0 equals 14, which is false. So we don't have a solution for the first equation. We just get a false statement. So we can leave that alone right there and just say that it's false. Now on the second equation, let's go to this one now. We can distribute the negative and we'll get x minus 4 equals a negative x minus 10. So now if we solve, we're going to add 4 to both sides, eliminating the 4. We get x equals negative x minus 6. Then we're going to add x to both sides, eliminating this x, and we get x plus x is 2x equals negative 6. So now we divide both sides by 2, and we get x equals negative 3. So now we have a solution, but we need to check it. So we're going to check our solution for x equals negative 3. So we're going to plug negative 3 into this equation. So we're going to say the absolute value of negative 3 minus 4 equals negative 3 plus 10, plugging it in. Negative 3 minus 4 is negative 7, so this is the absolute value of negative 7 equals negative 3 plus 10 is 7. The absolute value of negative 7 is 7, which equals 7, which is true. Since this is, I misspelled true. There we go, true. Since this is a true statement, that means negative 3 was true for a solution. So that is indeed our solution. We can box that and say that that is the solution. Okay, so here we have our second example, which is 2 times the absolute value of 3x minus 7 plus 10x equals 14x plus 24. So our absolute value is not isolated, so we need to isolate it. So first thing I'm going to do is subtract 10x from both sides, eliminating the 10x. So we get 2, absolute value of 3x minus 7 equals 4x plus 24. And now we can divide both sides by 2. We can put the 2 on both of these right here, and that'll work. So that reduces, and we get the absolute value of 3x minus 7 equals 2 divided by 2 is 2x plus 24 divided by 2 is 12. Sorry, I made a mistake there. So we get 2x plus 12 on the other side of the equal sign. So now it's isolated. Now I can do my two equations. I can say 3x minus 7 equals 2x plus 12, or 3x minus 7 equals a negative 2x plus 12. So now over here we're going to add 7 to both sides, and we get 3x equals 2x plus 19. Now we're going to subtract 2x from both sides, and we get x equals 19. Over here, we need to distribute the negative, so we're going to say 3x minus 7 equals negative 2x minus 12. And now we can solve. We can add 7 to both sides, eliminating the 7. So 3x equals negative 2x minus 5, I believe. Negative 12 plus 5 plus 7, sorry, negative 12 plus 7 is negative 5. Yeah, I believe that's true. So now we're going to add 2x to both sides, eliminating the 2x. So we get 5x equals negative 5. And now we divide by 5 on both sides, and we get x equals negative 1. So we need to check our solutions. I need to plug 19 back into the original. So we're going to say 2 times the absolute value of 3 times 19 minus 7 plus 10 times 19 equals 14 times 19 plus 24. 2 times the absolute value of 57 minus 7 plus 190 equals 266 plus 24. So now let's simplify this again. This will be 2 times the absolute value of 50 plus 190 equals 266 plus 24 is going to be 290. 2 times the absolute value of 50, that's going to be 2 times 50 plus 190 equals 290. That's going to be 100 plus 190, which equals 290. So that's 290 equals 290, which is true. So this is a solution, and we can box it. So now we need to check negative 1. So for negative 1, we're going to plug that into 2 times the absolute value of 3 times negative 1 minus 7 plus 10 times negative 1 equals 14 times negative 1 plus 24. So that's going to be 2 times the absolute value of negative 3 minus 7 plus 10 times negative 1, that's actually a minus 10, equals negative 14 plus 24. So this will be 2 times the absolute value of negative 10 minus 10 equals positive 10, because negative 14 plus 24 is positive 10. So here we're going to have 2 times 10 minus 10 equals 10. So now we're going to have 20 minus 10 equals 10. And 20 minus 10 is going to be 10 equals 10, which is true. So this is a true statement. So x equals negative 1 is also a solution. So we have two solutions. We have negative 1 and we have 19. Both of those solutions are acceptable for this problem. Well, I hope you enjoyed today's lesson on solving absolute value equations where the variable is on both sides. If you have any trouble or you have any questions regarding the material, send me a message on Schoology or you can send me a text. Have a great day.